Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Nursyahmi bin Sali and I'm here is going to present about my project Sarjana Muda. The title of my study is a study on maximum natural ventilation for a modern single-story house by using simulation software. In a nation like Malaysia, which is in a tropical climate, the issue of heat and humidity is one of the most critical challenges that must be addressed, particularly in residential buildings. Modern buildings are not planned with adequate cross-natural air circulation in mind, but with an emphasis of aesthetics. Due to warm climates, many homeowners choose air conditioning to reduce the air temperature, resulting in increased energy consumption. Hence, in this study aims to analyze the wind flow in a house by using computational fluid dynamics software and to compare the different size of windows for maximum natural ventilation in a modern single-story house. The location of this study is in Bandar Melaka, and the wind data collection was obtained from the Malaysian Meteorology Department, Malaysia. OnShape is the cloud-based software to construct the layout, and it is transferred to the simulation cloud-based software of ScaleScale to analyze the airflow in the house to gain thermal comfort. Four different sizes of windows are analyzed following the standard size from the Malaysian standards, and the finding shows that the bigger size of the windows influence the high wind speeds in the model. However, if the wind speeds compared to the impacts of occupants, high wind speeds in the building is not really suitable for thermal comfort. For the introduction, traditional structures are made in hot, humid environment, yet they seek natural ventilation to provide thermal comfort while reducing humidity. Buildings require fresh air to get rid of odors and enhance the quality of the environment within. In a few of these situations, spill air for adjacent areas is sufficient to offer the needed air changes and thermal comforts while consuming less energy. Natural ventilation systems rely on the air flow through the space to equalize pressure. At the end, the study will provide a layout of a single-story house with an adequate natural ventilation. The layout suggests that will follow the recommendation of cross-ventilation as stated in Malaysia's standard Code of Practice on Energy Efficiency and Use of Renewable Energy for Residential Buildings. The importance of the study is not only to improve residents' thermal comfort. The goal is to improve their energy efficiency and psychological acceptance of the building. The internal environment of the building is key of reaching these goals. For the methods, according to MS 1525, cross-ventilation is the wind forces cool outer air into the structure via an inlet, which warm internal air is sent outside via an outlet. In this study, the layout is following the standard of stated in Malaysian standard. The criteria that keep to the standards are as follows. Firstly, provide openings on opposite walls for optimum cross-ventilation effectiveness. However, if this is not possible, openings can be placed as on adjacent walls. Next, have equal inlets and outlets area to maximize airflow. Provide inlets on the windward sides and outlet on the leeward sides. Avoid obstruction between the inlets and outlets. Design opening to be easily accessible and operable by the occupants. Locates outlet opening on the windward sides at the occupied levels. And lastly, for cross-flow or two-sided ventilation, both windows openings should be open and effective room depth is equal or less than 12 meters. For the impact of air speed on occupants, for the speed that less than 0.25, the occupant sensation is unnoticed except at low air temperatures. For 0.25 to 0.5, feel fresh at comfortable temperatures but drafty at cool temperatures. For 0.5 to 1.0, generally pleasant when comfortable or warm, but causing constant awareness of air movement. For 1.0 to 1.5, acceptable in warm condition but can be from slightly to uncomfortably drafty. For more than 1.5 meter per second, it is acceptable only in very hot and humid conditions when no other relief is available. Requires corrective measure if comfort and productivity are to be maintained. For the result and discussion, as we can see, the bigger size of windows influence the high wind speed in the model. Based on the table, the mechanical effect for the size window of 1200 times 600 and 1200 times 1200 mm is too fast for desktop. This is too fast for desk work with loose paper, and for the occupant sensation is acceptable in warm conditions but can be from slightly to uncomfortable drafty. For 1200 times 1800 and 1200 times 2400 size of windows, the mechanical effects is equivalent to fast working speed, and for the occupant sensation is acceptable only in very hot and humid conditions when no other relief is available. It is requiring corrective measures if comfort and productivity are to be maintained. For a conclusion and recommendation, the primary purpose of this study is to analyze the airflow within the house using the ventilation simulation software are successfully conducted. The second purpose is to compare the various window sizes for optimal natural ventilation in modern single-story house. The comparison indicates that the velocity of wind flow will rise if the window's dimensions are increased. A building's natural ventilation performance is significantly affected by the opening size, shapes, and locations. Additionally, the wind-generated pressure fields in the region and across the opening influence the distribution of the air within the structures. Therefore, window size of 1200 times 600 and 1200 times 1200 are the most suitable for the layout. It is because the average wind speed is between the 1.5 meter per second and following to the Malaysian standards. It is suitable for the climate is measured, particularly in Malacca, where the study was conducted. Therefore, this study is required for a building to obtain an appropriate wind speeds or air velocity. Air velocity may cool a person's body through evaporation, directly affecting thermal comfort and enhancing tolerance for relatively higher air temperature when air velocity is greatly increased. For recommendation, researchers in the future can create the model layout either smaller or bigger than 900 square feet to provide a variety of results and suggestions. The future researchers can also conduct a study combining the wind speeds and the direction for a model layout. Lastly, due to the study experiencing constraints regarding installing the CFD software, it is suitable for the future researchers to use Autodesk computational fluid dynamics or ANSYS Fluent to get more detailed results. That's all from me. Thank you.